Hello, Joe from the Roland Academy here, and we're going to be taking apart RGB and CMYK process colours in 5 easy steps. Number 1. When we're talking about CMYK and RGB, we're talking about these as process colours, meaning that there are 3 well-chosen colours in each of these colour modes, which combine to create a whole range of other colours. The process refers to the amount of these colours that we combine in order to create the other colours. Number 2, if we start with CMYK, CMYK is a subtractive colour mode. This means that we start off with white and then we combine these colours in different amounts until we reach black. The white normally refers to the colour of your substrate when we're talking about digital printing. If we had 100% cyan, magenta and yellow, we would reach black, but this might not be a perfect black, so we introduce a key colour, which is black, meaning that if we were to print that colour, we don't have to have 300% ink, we can just have 100% ink to reach our black. If we have the cyan, magenta and yellow channels, these go from 0 to 100%. So the combination of these colours means that if we times 100 by 100 by 100, we have the possibility of around 1 million colours in the CMYK colour mode, depending on the device that is creating these colours. So CMYK is a subtractive colour mode because we're reducing the amount of light that would otherwise be reflected off of a white substrate. Black means that there is no light reflected. Number 3, if we look at RGB, this is an additive colour mode. This means that we start with black and then we add colours in varying wavelengths until we reach white. So 100% red, green and blue gives us white. If you had an RGB LED colour module, for example, and you turned on all of the lights, you would get a white light. And if you turn off all the lights, you have black, which means nothing. The RGB channels, instead of going from 0 to 100, go from 0 to 255. These are referring to the wavelengths of these colours. So if we times 255 by 255 by 255, we have around 16.5 million colours. Again, this is device dependent, depending on the device that is going to be either reading or showing these colours. So RGB is an additive colour mode because we're adding light sources in varying wavelengths that combine to make colours. When we're talking about devices, different devices can produce different colours. Digital printers, for example, always use a CMYK colour mode. There may be additional inks, such as a red, a green or an orange, or light colours, but the colour mode that these devices use is CMYK, meaning that they have inks which combine in different amounts onto a white substrate to create colour. RGB devices, such as a monitor, a digital camera and the human eye, use the RGB colour mode, meaning that they use or read or emit different light sources in order to create the different RGB colours. When we talk about colour gamut, as these different devices have different gamuts, as you can see in this diagram here, the RGB colour gamut is much larger than the CMYK colour gamut. This means that if we were going to print an RGB colour, it would need to be converted before being printed on a CMYK device. This is one of the reasons that we have colour management, and colour management is normally built into your software that runs your device.